Following on from my previous GCSE video, how do we find the quartiles for continuous and discrete data? So in the previous video, I showed you how we work out all the averages, so the mode, median, and mean from group data. Let's just quickly finish off by looking at the quartiles and also for discrete data when it's listed, because students always get this wrong. Okay, so if you guys think back to things like cumulative frequency diagrams, box plots, all of that stuff, the working out is basically the same on how to work out the median and the quartiles, because the quartiles just means the top or the most extreme 25% of values, whereas the median is about 50%. So the way in which we work out the quartiles for group data is the same as how we did for the median, which is linear interpolation. Okay, so how do we do that? Let's revise it. First thing we need to do is we need to work out the running total, the cumulative frequency, which I think I could fit here. Okay. Cumulative frequency is the running total, meaning we copy and paste the first number. It's saying the sixth person, so here, sorry, we're talking about the table showing information about daily commuting times of 60 employees. So we're saying up to the sixth person, so we're going to take all the 60 employees, we're going to put them all in a line from the shortest commute time to the longest commute time. And we're saying the first 6 people have a commuting time up to 10 minutes. Then we're going to add 7. 6 plus 7 is 13. Up to the 13th person, so remember they're all in order, the 13th person has commuting times 20 and under. Then we add 19, which, 32 or something. Yeah, buddy. Up to the 32nd person, their commuting times are 30. Then we add 15, 47. Up to the 47th person, the commuting time is 40. Then finally we add 13, which gives us the 60. So up to the 60th person, we have 50. Now for continuous data, which is what we're doing here when we look at grouped frequencies, it's always continuous. To work out the first quartile, which we call Q1, so the lower quartile is Q1, we just divide by 4. So the median we divide by 2. The lower quartile, 25% of values, means we divide by 4, which is the 15th person. Okay? Now, where is the 15th person? Well, the 15th person is between the 13th person and the 32nd. Okay, so my 15th person is between the 13th and the 32nd, which means their commuting time is somewhere between 20 and 30. So my Q1 is between 20 and 30. And this is where we do our linear interpolation. We're going to do our number line. We're saying Q1, which is the 15th person, is somewhere between the 13th person and the 32nd. Okay? Which meant that Q1 was between 20 and 30 minutes. Okay? I remember what we said about linear interpolation. This is basically cumulative frequency diagrams. This is an x-axis and a y-axis. So everything's in proportion because these represent coordinates. Okay? And the way we looked at it was in terms of basically triangles. But we don't have to draw a triangle. We're literally just saying this distance here relative to this distance is the same as this distance relative to the group size. So I'm just going to get rid of this because I don't need it. We've got all the information now. So this distance, which Q1's bigger, so that distance is Q1 take away 20. Relative, so as a fraction of its group size, which here is 10, is the same as this distance, which is 2, relative to its group size, which I'm pretty sure is 19. But you can never be too sure these days, 19. And now we rearrange for Q1. So we're going to multiply through by 10. Then we're going to add this 20 over. So Q1 is 2 over 19. Then we're going to multiply through by that denominator, which is 10. Then we're going to add 20. So Q1 is about, I'm going to round it, 2 divided by 19 times 10 plus 20, about 21.1. So it's 21.05. I'm just going to say about 21.1 minutes. Okay. So this is how you find Q1. Q3 would be 3/4. You would do this and then times by 3, because Q3, the upper quartile, is 75% of data. So yeah, that's how you do it for the quartiles here for continuous data. However, the exact commuting time, exact meaning listed data now, this is now discrete data. Okay, they're giving you the times. Here is an estimate. Okay, we don't know how these 6 people are distributed within this group. So the exact commuting time of 8 employees are shown below. Find the IQR, the interquartile range. So we need to work out Q1, Q3, subtract them. Now, how do we work out Q1 and Q3 from listed data? Now, there's different ways you could do it. You could find where the median is, find the median of medians. I don't like that way. I like doing it like this. The way you do it is you take your total value, which we call n, so your number of items, and then you divide by 4. Okay, so this is if you're doing Q1. Okay. If that answer is a decimal, then you round up. This is to locate, you guys all see that? Yeah. This is to locate where the median is. If it's an integer, so a whole number, you just add 0.5. Okay? So let me show you how that works with this. We have 8 employees. There's 8 numbers. So for Q1, it's 8 divided by 4, which is 2. That is an integer. So we add 0.5. It's to do with the median or medians. So when we add 0.5, that gives me 2.5. I'm looking for the 2.5th number. 1, 2, 2.5 is in the middle. So between my second and my third number, 2.5, I get 16.5. Okay. Then for Q3, so for Q3, it's basically the same thing, but times 3, right? It's 3 times n over 4. Well, if that's 2 times 3 is 6, which we're going to add 0.5, which is 6.5. 1, 2, 3, 4, 5, 6. So 6, 7. So we're looking for 6.5 in the middle. Well, between 21 and 21 is just 21. There we go. So my IQR, my interquartile range, is Q3 minus Q1, which is 21 minus 16.5, which is 4.5 minutes. Yeah, and this one also was minutes. So that's how we do quartiles for continuous data and listed discrete data. So make sure you favorite this video, like for more content, and subscribe for more maths content. Nice one, Mike.